Hello class and welcome back. Today we are in yet another video of our unit on geometric transformations. Today we're going to talk about using the rules that we learned in the last video. Remember the last presentation we talked about the rules for transformations, for translations, reflections, and rotations. Today we're going to talk about the actual application of these rules. Okay, so we're going to do a real example. We're going to do a few. We're going to do one example of each, and we'll do an additional example of reflection. Okay, so let's go through this first example here. So we want to reflect CTV across the y-axis. Now, generally, if I'm given the graph, it's easy for me to find these points for the y-axis, right? Or for the reflection across the y-axis. So normal case, we'd say, oh, it's not that hard. Now, what if instead I was given this question with same thing, right? We're still reflecting CTV across the y-axis, but the difference here is that they only give us a point. They give us the triangle, which is CTV, and they give us the points of C, T, and V respectively. They're the same points on the graph that I just showed you, so nothing's different. But what happens here? What do we do? That's when we have to use our rules. So we need to remember our transformation rules. So let me jot that down. I'm going to look at specifically our reflection rules, okay? Reflection rule. And that is that we take x comma y and we transform it to, in this case, since remember last class or last video, we were reflecting across the y-axis, so we need to change the x value, the sign of the x value. Okay, and that's our rule. So let's try an example right here. Let's make this in a different color, and let's look at C. C has the point 3 comma negative 1. And here I can reflect across the y-axis, which means all I'm going to do is change the sign of the x value. So now I'm going to change that to -3 and leave -1 the same. Okay, same exact step for point T. Point T was 3 comma -5. And if I reflect across the y-axis, all I'm doing is changing that sign of the x value right here. And that should be -3 comma -5. We keep that -5 the same. Okay, and then finally the same with point V. 5 comma -1 reflects across the y-axis, and that becomes -5 comma -1. And again, notice how when we say this sign right here, that's not saying that we're going to make the x negative, which in this case we do. It just means we're changing the sign, right? Notice how here, of course, this was a +3, and then it became a -3. This was a +3. It also became a -3. And then a +5 became a -5. But notice how even though this is a positive y here, right, it doesn't mean that y has to be positive. It just means we don't change anything, right? -1 still is -1. -5 is still -5. And then -1 is still -1. Okay, so nothing changed for the y values, only for the x values. All right, let's look at another example. Let's check this one out. Translation, 1 unit to the left and 2 units up. Okay, let's write down our rule. What is our rule for translations? Well, we go from x comma y, and then we go to x plus a, comma y plus b. Okay, and in this case, our a is our horizontal shift. And keep that in mind because this is a very common phrase to use for horizontal and vertical shift, A and B values. This is not just used in this one skill. Many times you will refer to the A value as a horizontal shift. And so B is our vertical shift. In this case, they want us to go 1 unit to the left. So in this, we're doing 1 unit to the left, which means, remember, if we go to the left, we are going to subtract from our values, right? So that's going in a negative direction. So the horizontal shift is -1. Okay, and then the vertical shift, since we're going up, that's a positive value, 2 units up, then we are going to add 2. Okay, so let's look at our actual points on the graph. And so we are going to shift these. We are going to subtract 1 from the x value, right? So this is x value. And then we're going to add 2 to the y value. So let's do that. Let's go back to our d value, or d point. And d now becomes d prime, our transform point, which in this case is we're going to subtract 1 from x, so -3. And we're going to add 2 to y, which means this is going to become +3. Okay, so all we did was we subtracted 1 from the x value, which is -2. And then we added 2 to the y value. Let's continue going. W becomes w prime. X is -1, so in this case, it can become -2. And then y is +1, so it will become +3. For f, it will now become f prime. We take -1, subtract 1 from it, becomes -2. We take -3, we add 2 to it, and that becomes -1. Same thing with e. This becomes e prime. And we have 3. If we subtract 1 from 3, we get +2. And if we add 2 to -2, we get 0. And those should be my points. And if you notice, I can graph these on the actual graph here. So this would be D, this would be W, this would be -2, 1 is 2, -1 is F prime. This is D prime, and this is W prime. And then E prime is -2, 0, or sorry, +2, 0. This is E prime. And notice how that looks like a shift, 3 units up and 1 unit to the left. Okay. All right, let's look at another example. Let's look at a reflection across the x-axis. This is hard to see because we would have to reflect it across this line. So it's not that easy when we're doing it on patty paper. Doing this on or using the rules is best. So as we said, the reflection rule is x, y now becomes, if we're reflecting across the x-axis, we change the y value. So I'm going to now make it x, -y, or we're just saying a change in y. Okay, let's quickly pull up these values of each point. And again, all we're going to do here is we are going to reflect across the x-axis. That just means that we're going to keep the x values by themselves as they are, right? And then we will make the y values change in their sign. Okay, so let's try this. And maybe I'll do it in a different color just to show it here. So h prime now becomes -3, -1, because we're just changing the sign. M prime becomes -2, -1. We're just changing the sign of y. B becomes -3, 0, because we don't have such thing as -0. You can't have nothing. And then 0, +3. And that becomes our actual points for the reflection. Okay? Let's look at one more example. All right, so we have a rotation across or clockwise about the origin. 90 degrees, or a quarter turn, right? I can say that, quarter turn. Okay, and so we're doing this clockwise, so we're going to turn it this way. Okay, it'll be somewhere in this corner, this quadrant, in between quadrants 4 and 3. Okay. Okay, so what should my rule be for a rotation 90 degrees clockwise about the origin? Remember, this is the same as a 270-degree rotation counterclockwise across the origin. So our rule for a 270-degree counterclockwise or 90-degree clockwise is, and maybe I'll put this in a different color, x comma y transforms to y comma negative x. All right, and let me do this a little bit nicer, neater. Y comma negative x. Okay, so again, all we have to do here is find out what the values are. And what we're saying there about y comma negative x, it just means we're going to flip those numbers. So now x becomes y becomes x, and we're going to change the sign of our new y value. So let's check that out right now. And so again, let's look at our rule. Our rule says take x and y and then flip it. Now y becomes the x value, and then x becomes the y value, but we change the sign. So let's do that. Let's change it. So we're going to flip it around. Instead of x, y, we're going to write this as y, x. Okay? And then finally, since we have that negative here, right? We're not saying that this is negative. We're just saying change the sign. So we're going to change the sign of that y value that we just changed from an x value. So now our point becomes 3 comma negative 4. Okay? Same thing for point k. Let's flip this the values. So instead of 5 comma 3, we're going to have 3 comma 5. And again, same thing. Let's change that x value. It was a positive 5. So now it's going to become a negative 5. Okay. Keep going. Let's flip those values. So now x becomes y becomes x. So now we get 0 comma 5. And again, we are going to get negative 5. Okay. And then finally, we have 2 comma negative 2. Be very careful. We're going to change these, flip these, negative 2 comma 2. And then, of course, we have to then change the sign. It becomes negative 2 comma negative 2.